So if you can get the same answer regardless of which row or column you expand on, which row or column should you choose? So let's take a look at this example right here. If you had to do this one, which row or column would be the best one to expand on? Column 1 would. Why? Okay, because we have fairly small numbers. We've got ones for the entries in these two entries right here. And then we've got a 0 there. Probably the next best choice? Probably row 1 or row 2. Row 1 because it's all 1. Row 2 because it's got a 0 in it, even though it's got the -5 there. Okay? So here's what I'd like to do. Would you 4 people right here, would you guys do column 1? Okay, expand on column 1. Okay? Would you guys right here in these 2 rows right here, would you do row 1? So you guys are going to do column 1. You guys are going to do row 1. And would you 4 right here, would you guys do row 2? Okay? Expand on row 2. Okay, if you're at all not sure, let me run through what we went through yesterday. If I'm going to do column 1, like these guys are doing over here, the first thing I'm going to do is I'm going to look at this position right here, and I'm going to say, what's the sign associated with this position, that whole checkerboard of pluses and minuses? I'm going to put a plus. I'm going to write down the number that's there, and then I'm going to write down its minor. Its minor, cross out the row and column, 1, -5, -2, 3. Then I go to this one. I think, what's the sign associated with the position? Negative. What's the number that's there? 0. Cross out the row and the column. 1, 1, -2, 3. Then I go to this one right here. The sign associated with that position is positive. The number that's there is a 1. And then I write down its minor, crossing out the row and the column. And then go from there. Okay? Okay, is that right? Okay, this is the first column right here. This one is the first row, and this one is the second row. Okay, does that match up? Okay, what did you guys get for this one? Okay, Cameron says -8 with a question mark at the end. Brandon, what do you say?
Sure.
Did you get it? Did you get it done?
Not yet.
I'm gonna have to take your donut back. What did you get? -11? -11. Okay, let's check and see. So again, the 2x2 determinants hopefully are pretty easy. Here's what we do, multiply down. Now, if you need to, you could do this. I'm going to write a 1 outside, and then I'm going to write down 3 minus 10. Then I can write down the 0. It doesn't matter what this is. I am going to write down what it is, though. So we end up with a 3 minus -2. Here we end up with a 1, and then this is going to be -5 minus 1. Is that right? So this is -7. This is 0, and this is a -6. Correct? -13. Is that right? Okay, so if this is correct, then I should get the exact same answer when I do this one. So if I go through and do this one's going to be 1 times, this is going to be 3 minus 10. This is going to be -1 outside, or I could just write a minus there if I wanted. This is going to be 0 plus 5. And then this is going to be, in parentheses, I'm just going to have 0 minus 1. So I have -7 from this one. I have -5 from this one and -1 from that one. -13, pretty good evidence here, right? And did you guys end up with the same thing? Did you get negative 13 on this one? Okay. If you didn't, if you made a mistake somewhere, okay, correct me if I'm wrong, but these are not very hard. They're just a little tedious, and there are a lot of little calculations. So just like when we worked with matrices before, you've got to be really careful about this. Okay, any questions? Okay, which row or column should we expand on here? Probably, what'd you say? Probably column 1. Why, Miranda? There's 2 1s. We want to keep the numbers as small as possible, and usually working with fewer negatives makes us end up with the correct answer. So let's go ahead and expand on column 1. Okay, go ahead and get your answer, and let's see if it matches up with what everybody else gets. We'll all do it the same this time. Okay, if this were a test question and I wanted to make sure I got it right, I would even do this. If I'm going to expand on column 1, I'm going to think sign associated with that position is positive, so I'm going to write a 3. I'm going to cross out the row and column, and I'm going to write negative 1, 5, 2, negative 2. Sign associated with that position is negative. The number that's there is a 1. Its minor is 4, 2, 2, negative 2. And then sign associated with that position is positive. The number there that is a 1. And then I've got 4, 2, negative 1, 5. And then I'm going to do 3 times. That would be 2, minus 10. Then I'm going to do minus. That would be negative 8, minus 4. And then this is going to be plus, and this is going to be a 20 minus a minus 2. So that's going to be a plus 2. So that's going to be 3 times negative 8. This is going to be negative 12, and then this is going to be plus 22. So I get negative 24 plus 12 plus 22. So I put all these together, I end up with positive 10. Any questions? Okay, raise your hand if you got that right. Okay, you'll have one of these on the test. Okay, absolutely guaranteed. Okay, I'm going to show you a different technique that you can use, and if you've worked with determinants before, you may have seen this. This only works for 2x2s and for 3x3s. This is called diagonals. We already know how to use diagonals on a 2x2, but here's the problem using diagonals on a 3x3. If I went down like this and up like this, what have I done? Left out some numbers, right? I left out those 4 numbers. So you can do diagonals a couple of different ways. Let me show you the way I like to do it to make sure I get everything. And this is just my personal preference. I'll show you a different way if you have trouble seeing this pattern. So if I multiply down, I multiply those 3 numbers together. If I multiply down here, I only have 2 numbers to work with there. So what I do is I swing around and I pick up that one right there. Okay? When I'm going down here, I hit these 2 and then I swing around and pick that one up. Notice the symmetry there. We're multiplying 3 numbers together, 3 entries together in each one of these. So on this one, I've got 1, 1, and 3, so that's going to be 3. On this one, I've got 0, and this is what's awesome about it. I've got 0 times, who cares what these other ones are? That's going to be 0. And then I've got 3 times negative 5. That's going to be negative 15. Swing over here, pick up the 3. That's going to be a negative 45. Any questions there? That's all the downward direction. Now, when we go upward, we're going to subtract everything. So I like writing a minus. I put a set of parentheses, and then I'm going to go upward and hit that diagonal. That's going to be a minus 6. If I hit the 2 of these, I've got to swing around and pick that one up. So that's going to be a negative 10. And if I do the 2 of these, I swing around and I pick that one up right there. Because one of them is a 0. Again, these are all factors in a multiplication problem. I end up with 0 right here. So with these guys, I end up with, this is negative 42, okay? I'm going to go ahead and write down minus, let's see what we get here. This is going to be, what do we got? Negative 16. So this is going to be plus 16. So the answer is going to be negative 26. So just like a 2x2 with the diagonals going down, multiply 3 factors together, add those together. When you're going upward, we're going to subtract them or just put 1 minus out in front. I find that a little bit easier. Any questions about that? Yeah. No. No, in fact, I'd prefer you use the cofactor expansion because when I took a linear algebra class, I thought, come on, it's got to work. It works for a 2 by 2 and a 3 by 3, so I wrote down a 4 by 4 and a 5 by 5 and tried it, and guess what? Doesn't work. Doesn't work. As much as you'd like it to, and as easy as that would be, it doesn't work. Okay, there is one other method that you can use that some of you might like. I'm going to rewrite the first two columns, so I'm going to write 1, 0, and 3, and 2, 3, 1, and 2. And then you can see the columns that we'd the diagonals, 1, 2, 3. You can do that, and then you can go upward. Those are the same numbers. Watch. There's a 3 right there. Okay. There's a minus 45 right there. There's a 0. Going upward, we get negative 6. This is negative 10, and that last one would be 0. So if you want to rewrite those columns, the one thing I'd advise you if you're going to do that, takes, in my opinion, it's a little bit more work, and you have to make sure that you space them evenly, because if you bunch these up, so if you were to do something like this, if you wrote it like this, 1, 0, and 3, and 3, and 1, and 2, it's hard to see what those diagonals are, so you have to keep everything equally spaced, just like we've talked about before. Matrices are organized arrays, arrangements of numbers, okay, so you got to keep them nice and equally spaced. Any questions there? Okay, cofactor expansion works for everything. You absolutely have to know that. You can use diagonals for a 2 by 2 and a 3 by 3, but let's take a look at this one right here. This is kind of interesting. Use cofactor expansion. So just watch. I'm going to expand on the first row. What's the sign associated with this position? Positive. What's the number? 3. What's its minor? Its minor is 2. Cross out the row and the column. Its minor would be 2. Okay? What's the sign associated with this position? Negative. What's the number? 1. And what's its minor? 4. So I get 3 times 2, that's 6, minus 4 is 2. Same answer I get if I do this, 6, and then subtract the upward diagonal, I still get a 2. Okay? So cofactor expansion works on every single one of them. The diagonal technique will work on 2s and 3s. After you get outside that, does not work. Okay, any questions? Okay. All right. You have a half an hour right now. You can use that